This is a tricky GRE physics question. We are required to find the total acceleration of the mass released horizontally as shown as a function of the angle theta. A common strategy is to use energy conservation, which says the total energy of the mass is constant along the orbit. Let us pick the 2 points at angle 0 and any angle later called theta. The total energy at theta equals 0 is the sum of kinetic and potential energies. Let us assume the potential energy is 0 at the lowest point of the path. The total energy is only the potential energy since the mass when release has 0 velocity. The energy is thus just m times gr, which is the vertical distance to the mass when it is first released. At any later point when the angle is theta, the total energy is the kinetic energy plus the potential energy, which is m times g times the vertical distance, which is or minus r sine theta. Now, the two energy expressions for the different angles has to be the same. Doing little algebra, we get an expression for the velocity in terms of theta. Now, the radial acceleration for such path is equal to v squared over r. Inserting the expression for v squared we find that the radial acceleration is 2g sine theta. The other component of the acceleration is due to gravity, which is the tangential acceleration. Gravity force is making the angle theta with tangent of the path, thus, the tangential acceleration is g cosine theta. Now, we are asked for the total acceleration, which the square root of the sum of each component squared. Since cosine squared is 1 minus sine squared, we get then the expression g times square root of 3 sine squared plus 1, which is answer E.